Hello, everyone. Good morning, good afternoon, good evening, wherever you are. My name is Sam. I'm a solutions engineer at HashiCorp, currently based in Melbourne, Australia, where it's a beautiful blue day. And I'm very excited to walk you through this snapshot that I have at the moment. Keep in mind that if you do have questions, please make sure to use the Q&A tab or leave it in the chat as well. I'll do my best to answer it. Might be a little bit short on time today, but no worries. I'll do my best to actually follow up with you after as well. With that said, let's dive in. So some prerequisites before we even begin, right? I'm going to have the level of expectations that some people here, you guys already know a bit about Terraform. So that's why you're here. I'll be using a bit of GitHub just to walk you through the way I store some of my code. And for our Terraform enterprise or cloud platforms, I'm actually using Terraform Cloud today, which is HashiCorp's managed service offering, whereas Terraform Enterprise is the self-managed version. It does something very similar. That's literally like the big difference, right? And so with that said, let's dive in. Where I always like to start off first is, where do I even get inspired to create this snapshot about migrating from open source to Terraform Enterprise? And I call it the situation. So let me set the scene here. In preparation for this presentation, what I've done is that I've actually looked back on the way Terraform has been adopted over the last couple of years. And something that really stood out to me just last year was during the Octoverse, which GitHub has now hosted and published. The fastest growing language is actually the HashiCorp configuration language, which is the language used to power Terraform tooling. And that's amazing news because that really solidifies that, hey, infrastructure as code, it's here to stay. It's helping us automate, be more efficient in our workflows, and it's helping organizations like yourselves, like the wider community, move into things like cloud computing, helping them go work across different multi-cloud strategies, hybrid cloud strategies. And we're always so grateful for the community for continuously giving us those feedback to continuously improve Terraform. But as always, with this snapshot, there is a bit of a complication, right? And this complication really comes around Terraform itself. Now, we know that Terraform is powerful. It helps us write code, write configuration file, and provision those resources for us. But to really unleash the potential, we see a lot of customers, especially those who are using open source, they do something that we define as scaffolding. Now, by definition, scaffolding is all about a temporary structure built around a building to facilitate development. Now, likewise, for our customers using the Terraform open source, we see them build use a lot of different systems and tools to build around Terraform to do this scaffolding. Terraform generates that state file. Where do we want to store it, right? We have to store it into a remote state backend. We have an engineer doing the whole setup process for us, and they do it there. And then things like our access controls, who have access to those state files. We need someone to maintain that as well. And while scaffolding is really useful for teams that are at a smaller scale, because we know each individual on the team has a key role to play. But now the question would be, hey, what happens if this team is going to grow? Right? What happens if we actually need to integrate other teams into our workflows itself? Then we start realizing that this scaffolding is a little bit more brittle than we thought, because actually only a few key individuals knows what's actually happening in these workflows. Maybe maybe there wasn't even time to write proper documentation. So if we onboard a new engineer, what does that look like? Right? They're going to have to take time out of their day, not just learning Terraform, but also learning how to maintain what is built around Terraform itself. And this is something that HashiCorp realized at the beginning. And so this is where they actually established what is known as Terraform Cloud or Terraform Enterprise. For today's sake, I'm just going to call it TFC or TFE, just for making it simpler. And the way TFC and TFE was built is that at the very top, we have the self-managed open source Terraform that generates that state for us. We can now codify our infrastructure. So we have code as the truth of how the infrastructure looks like. And we have modules which are reusable. But then we start realizing, hey, we need to actually put in a few pillars in place to build out our platform. And the first is collaboration. We're going to take away all the maintenance, all the need for you to store the state files remotely. We'll do that state management for you. And in the same time, we start to realize, hey, you're going to need to start managing individual code repositories, storing your Terraform code. And that's where projects and workspaces come in. We help you seamlessly integrate with your version control system. We now have a private module registry for you to store your modules in there. So anyone within the org who needs access to those modules, they know exactly where to go to get that information. They don't have to sift through the huge GitHub repositories to find it. Over time, we start taking into account compliance and management. So we want to be able to make sure that, all right, we've got all these workspaces and projects pieces here and there. How do we actually manage controls? We don't want everyone to have access to that state file, right? So with this access control at the workspace level, we can give granular access to individuals and the teams to make sure that, hey, only Sam, who's part of the security team, can access the security layer state file. No one else has access to that. And over time, we start to put in things like policy as code. So we have Sentinel, and now we also support open policy agents to make sure that there's a compliance layer in place to help us make sure that the code is meeting certain requirements, whether it's costs, whether it's naming conventions, whether it's who has accessibility to use certain modules. And then we start enhancing those workflows with things like drift detection, continuous validation. And finally, we've realized that we don't just look at the current and past state, we also look at the future state. What happens if we need to start helping application developers manage their own infrastructure resources? We don't want the platform team to have to go through the whole ticketing process. So let's make their life easier. Let's give them the ability to self-service. So the no-code provisioning is something that just recently came out in beta for Terraform Cloud. And that's where application developers can go in, find the module that they need, fill in the resources, and then we generate those and we provision those resources for them. Now, the differences between Terraform Cloud, Terraform Enterprise. Terraform Cloud is fully managed by HashiCorp. Terraform Enterprise, you manage it within your own environments, and there are some feature parity that needs to be that's still not up to parity between each other, but it will still be on the roadmap for one or the other. Things like no-code provisioning, for example. Of course, now we have an enterprise platform, right? We have this open source pace. Now we have an enterprise platform. So the main question now is the entirety of the snapshot, which is how do we migrate from open source to Terraform Enterprise? And that's where I'm here to walk you through some of the high-level steps that I've curated today. And the idea behind all the steps is that it gives you an idea to think about your workflows and how you want to adopt the platform itself for your own use cases. The one thing that I always share with customers before we even go into the migration workflow is that when you have Terraform Cloud or Terraform Enterprise, you don't want to immediately start migrating those traditional workflows. There's no immediate return on value there. Instead, there's actually going to be a couple more phases that you want to think about before we even get to there. So phase one, you need to think about how do we adopt the platform first? And that is looking at new projects, making sure that instead of running on our traditional Terraform workflows, let's start using Terraform Cloud or Terraform Enterprise to host our state files, to manage those use cases there, whether it's provisioning virtual machines or doing other bits and pieces. Then we can start expanding the use cases to increase the adoption a little bit more. Maybe we can start thinking about, hey, let's actually put a policy for this use case to manage cost. And only then at phase three, when our customers when your team, your stakeholders are comfortable using the platform in phase one, phase two, we can start thinking about, all right, now it's time for us to migrate those traditional workflows. And this is what those migration steps can look like for your organization. So I put it at a high level. It's really 4 key steps. I put a 5th one there. It's just a bit of a fun bits and pieces that we can add to this workflow. But first is determine the code structure. From that code structure, we can start identifying how we can provision those micro infrastructure workspaces. Then we migrate those state files before we can start linking which type of workflows that we want to have for each individual workspaces. And I'll dive into all these concepts just a little bit more as well as we go through this presentation. So step 1. Determining the code structure. Now, this is actually where we can actually look at perhaps our application stack to see how can we actually decompose traditional monolithic configurations into their own individual layers. And the reason why we want to do that is because we might have multiple individuals, multiple teams within the project that actually manage different layers of this configuration. And so in order for us to start identifying, hey, we got a front-end app, we want to put a whole layer to it, there's really 4 key principles I want you to keep in mind. First is blast radius. One thing I always stress is that we want to avoid monorepos simply because what happens if the repository is breached? You're going to lose a lot of things, not just your code, right? You're going to lose a lot of access and key information in there. So we want to start thinking about how can we decompose our code and separate it out a little bit more. And the way we want to separate it out is by using something called resource groupings. So we can separate those applications into their various layers and something that actually related to each other. I might have a database attached to my application. If I want to manage all the databases at one layer, I can create a database layer with all my database infrastructure resources as part of the code in there. At the same time, my 3rd principle I want to keep in mind is the rate of change. I'm not going to put something that is constantly there's a dynamic resource next to a static resource. And the reason being, if I put them next to each other and this dynamic resource keeps changing over time, there's potential it might actually affect the way my static resource is gonna operate. And finally, this is the best opportunity for us to bring security top of mind. We've all known there's so many security incidents that's happened in the past year. And this is the best time for us to start following some basic principles, like the principle of least privilege. That means at each layer, we want to make sure that only the teams and only the users who should have access to those layers can access it. Everyone else will need to go through a permission request, or maybe they need to go through a certain workflow before they can actually get access to those different layers. So from all those principles, if we look at this basic 3-tier infrastructure, I might create a security layer. This security layer that contains my Azure AD, I might want to put in my access group in there, my security groups, my MFA resources. Those are going to be grouped in one security layer. Then I have my VNet layer. So I know I'm going to need to put my subnets in there, my net gateways, maybe some sort of networking infrastructure resources. That's all going to go into this layer. And finally, my application layer, right? This contains my web app. I will probably need to put my load balancer in there. I might have a scale set. I might also want to make sure I put in my security group so I have access to some information inside my infrastructure. So this is the way we can actually separate our application stack into different layers and start determining what that code structure will look like. And this relates to step 2, which is micro infrastructure workspaces. So something that is new to Terraform Cloud and potentially coming into Terraform Enterprise as well, I believe, there's actually something called projects. So where projects actually came about was traditionally, a lot of our customers have multiple organizations that they have to separate the different projects. And that becomes very cumbersome, especially when you want to share information with each other, or when you want to have visibility, but now you have to log into three different organizations. That's quite a complexity there. So what we've done is actually we've implemented projects. So now we actually only need one organization and we have visibility into the different projects. And then from those projects, we can add in team-based permissions. So team A can be a part of project A, would have certain permissions that they can have to operate within that project itself. And then we have something called workspaces. Now, workspaces is very unique to Terraform Cloud. Now, workspaces is a collection of everything that Terraform is going to need to run, like your configuration file, your variables, and your state data. And where workspaces actually is powerful is because we've already in step 1 determined all the different layers. Now we can use those workspaces to map at a 1-to-1 ratio potentially to those different code layers that we have. So I have a security layer that's going to be a security workspace, a web layer that's going to be my web workspace. And on top of that, with Terraform Cloud, Terraform Enterprise, we can also do things like more granular access control. At the same time, we can also integrate version control system directly to those workspaces as well to start automating those workflows. And something that I picked up when I was browsing through LinkedIn, as you would, is an article written by Popin Sinapati. He's an engineer at Casios, and he's written this article talking about how projects can actually help you scale your workspaces. So what you see on the screen right now is you have 3 different teams, team A, B, and C. They're in charge of their own projects, A, B, and C. And inside each of those projects, you have security workspace, VNet workspace, web workspace, but they're all correlated to project A. But there's this segregation now, there's this separation now. Team A can't access anything in team B can't access anything in team C, and vice versa. So now we actually have better controls over what this organization is going to look like. At the same time, we can start mapping our workspaces to operate very similar to a microservices architecture or a micro infrastructure, as we call it. So what I've actually done as part of this demonstration is I've actually used the TFE provider and operating in Terraform Cloud. Inside, I actually have a projects workspace. Now, inside my project workspace, I've linked it to my GitHub repo. Inside this GitHub repo, I have a resource that's actually generating a new project, which I call application A, as you see over here. And inside my workspaces repo, I have 3 resources that I'm using. It's creating for me my workspaces called application A security, VNet, and then web as well. So with this TFE provider, I can actually start manipulating the way my TFC org will look like and keep everything as infrastructure as code as well. And why this is important is because now I can actually start mapping the projects with those relevant workspaces to those projects. And this in turn ties me into step 3, which is migrating that state file. So now all I need to do when I want to migrate my state file is I actually have something called a cloud block in Terraform. So this cloud block, I need to specify what this organization is called. If I'm using Terraform Enterprise, I'll specify where Terraform Enterprise is actually hosted at. Now, if you're using Terraform Cloud, the host name is always going to be app.terraform.io. And then next I need to do is specify the workspace name. In this case, I have my workspace name is going to be application A security. But one thing that I want to share at this particular step is that it's also a good time to think about, hey, what sort of repository strategies do I want to have in place? Because this is a good time to look at the way you're operating in your workflow right now. Maybe you want to use something like long-running branches. Maybe you want to actually store your code into subdirectories, and each directory is a representation of your dev environment, your tests, maybe even your prod environment. Maybe now is the best way for us to see how a multi-repo infrastructure can actually look like for our org. As you're going through this phase, it's a good way to think about what that repository strategy will look like, and we can refactor as we need for the code to match what that strategy is going to be for you and your team or your organization. Now, I want to share that I do actually have a YouTube video that I created on the HashiCorp website that actually walks through a bit of the basics on how you can structure repositories for those Terraform Cloud workspaces. And it's something that I'd love for you to check out. It might be pretty useful. I wish I can say, please like, share, and subscribe, but it's not my channel, it's HashiCorp's. Even then, I hope it helps you. So now let's actually look at how we can use this cloud block, right? So inside my screen on the right, you see that I have if I click my application, my tree, I have my security, my VNet, my web workspace. For the interest of time, I'm not going to migrate all of them. I'll just migrate my security folder. So I'm going to change directory in my security folder. And what you see is that I have a Terraform state file. This is stored locally. It's got all my information in there. And now I'm going to actually use the cloud block. So if I uncomment this code, you'll see that I specify my organization name, my host name. As you know, this is optional if you're using Terraform Cloud, but it's always good practice to put it in there. And I'm going to specify this application A security. Now, if you look on the left side of the screen, if I click on the stats, the states tab, I actually have no states saved right now. This is just to show you that, hey, this is empty. What is it going to look like when I want to migrate that state over? So I'm going to do Terraform initialize. And because I've actually put in this cloud block, my CLI knows that it needs to connect to Terraform Cloud. And from there, the CLI is going to ask me, hey, as part of this migration to Terraform Cloud, do you also want me to migrate your snapshot, your state files into Terraform Cloud? Of which I'm going to reply, yes. So you see my state file, what it's going to do is it's actually going to move everything inside the state file right into this application A security workspace. Quick refresh, and then magically you'll see, hey, that's a new state now that's migrated into Terraform Cloud. And likewise, if you do so with Terraform Enterprise, the whole process is also very similar. So what you've actually just seen is that, hey, this is the best time at step 3 for me to review my Git repository strategy, refactor my code as necessary, and then use this cloud block to start migrating my states into Terraform Cloud and Terraform Enterprise. And this comes up into the final step, which is now I can actually start linking my Git repositories to that workspace. And this is something that's built into Terraform Cloud and Terraform Enterprise, is the ability to seamlessly integrate your repositories into those workflows. And what's going to happen is that if I integrate it this way, any merge that I do, it will automatically trigger the workflow in Terraform Cloud to start running. As part of the workflow, I might even do things like cost estimation and policy checks. And the beauty about VCS connection is that it supports Azure DevOps, Bitbucket, GitHub, GitLab, really all the major players at this stage. So actually, we're going to see that in action right now. So if I go into settings, if I click version control, you see that I have not connected anything. So I'm going to click connect to version control. And now I have 3 different workflows. I'm not going to dive into each of these deeply today, but a version control workflow is the most common that's typically used and is also the most structured. But if you realize that you need a more flexible approach, hey, and then you're using a CI pipeline, the API-driven workflow is probably best suited for you. If you're a team that likes to operate within the CLI on your local computer, we also have a CLI-driven workflow. And this essentially gives you flexibility on the way you want to operate Terraform. So in this VCS, you see that, hey, these are the 4 major version control providers that we have. I'm going to use my GitHub. I have a marketing snapshot dedicated to this. So I select that option. I'm going to put auto apply. and I'll update that VCS settings. Almost immediately, what you see is that, hey, it's going to do a plan. It's going to make sure that the state file is what it was said when I imported it over. And you also see that now it automatically do the cost estimation for me. So really, that's steps 1, 2, and 3, 4, all done. The fun part now is that we can dive into a bit more of the advanced capabilities now. So with TFC and TFE, we have something called policy as a code, which is both Sentinel, and we also support open policy agents. Essentially, what we can do is that we can codify policies to help start automating guardrails around our provisioning process. These guardrails can represent things like making sure that as we're provisioning virtual machines, we don't want it to cost more than $50 for our dev environment, for example. Or maybe it needs to meet certain naming conventions in our Terraform code. Or maybe this is using modules inside our workspaces. We need to make sure that you're in the right team to use a particular module. And all these policies allows us to enforce the workflow in 3 different levels, whether it's advisory, soft mandatory, or hard mandatory. At the same time, we can implement something called run tasks. Now, the beauty about run tasks is that we work with third-party providers to allow a bit more seamless integrations into the Terraform Cloud workflow. And with this run task, we can use things like HTTP Packer. If I'm using a particular image, I want to make sure the image is always using the latest version. If I'm using Sneak, I can use Sneak to do code analysis for me as I'm going through this workflow, or maybe InfoCost to have a better detailed look at what the cost estimation is going to look like. And the idea about run tasks is that I can actually use it whether it's pre-plan, post-plan, or even during the pre-apply phases as well. So that's something that's extremely worth checking out, and it's something I highly recommend as part of that workflow. All right, so you saw me talk about a few different things and a very short and quick, simple demo about migrating state files into Terraform Cloud. I'm just going to quickly summarize today because it looks like we're just about at time. So something I want you to take away from this presentation, if not for that very nice demo that we had before, is that when you start migrating and start adopting Terraform Cloud and Terraform Enterprise, keep in mind there's 4 key phases. Phase 1, adopting the platform. Look for quick wins. Look for ways that you can actually show immediate return of value that this platform brings to you. Phase 2, look at how you can expand the use cases a little bit more, right? Add in policies, add in cost estimation, drift detection, maybe continuous validation to help you enhance those workflows. When you're ready, look at phase 3. This is the best time for you to now migrate those traditional workflows right into your Terraform Cloud or your Terraform Enterprise platforms. And then it's phase 4, something that we didn't really talk about. But now, when phase 1 to 3 is complete, you can start looking at integrating the other teams into your organization. And the beauty about Terraform Cloud is, as you scale and grow your organization, we'll scale and grow alongside with you as well. And when we talk about migration workflow, remember, number 1, determine the code structure using the 4 principles: blast radius, resource grouping, rate of change, as well as the principles of least privilege. Step 2, we can now map those different layers to our infrastructure workspaces, right? And we can also start separating those different applications or projects into Terraform Cloud projects. And then step 3, this is the best time for you to look at your Git repository management strategies and then start migrating those state files into Terraform Cloud. And finally, step 4, identify which workflow works best for your workspaces or your use cases, whether it's a version control workflow, the CLI-driven workflow, or the API-driven workflow. And finally, enhance those workflows a little bit more. Get that faster feedback, whether it's through policy as a code, whether it's through runtime integration, drift detection, or maybe you also want to try out supporting your application team, and you can start building out no-code provisioning as part of the platform as well. So really, that's all the presentation that I have today. And I am going to put it here. A big thank you.